Hello, student. Do you hear me well?
Yes, Professor.
Yes. Okay, I'm going. All right. Let's do that by. Let's do that by. Polling. Oh, this is great. 28, hear me well. 29. 11, haven't. Okay, 8. Okay, I get 33 response. Okay, Daniel, you want to say something? Okay. All right. Can you? Okay, I'm going to ask you to stop sending chats and things like that because it's disturbing the class. And then I'm now going to start the lecture. All right. Okay. All right. Stop sending messages. If you want to ask me a question, you raise your hand. All right. So I have a few announcements to make. So this is, although this is a recess, a week of recess, I'm teaching this class officially now, like a regular class. And Wednesday, we'll have also official class. Another announcement is that homework 5 is due next Monday, and it's due online. You just need to click on homework 5, the entry of homework 5, and you will be automatically sent to the online submission. All right. So I see that Luis Hernandez is raising his hand to say something. So this is a big class, all right? So I will ask you to, if you want to ask something, you raise your hand only if you want to ask something, and because it's a big class, all right? Okay, so I'm going to start. All right, so Luis Hernandez is raising his hand. Do you want to say something? Gregory?
I don't think Lewis can hear you. He's having audio issues.
All right.
But that's probably a local issue because I think everyone else can hear you.
Okay.
But I did have a question though. Are you going to take attendance?
Yes. No, but in fact, I could simply look at the list of students who are joining the session, and that will be enough. All right. So let's start the class. So let's do some review of what we were doing before. The goal was to find the inverse Z transform of. So Tenzin, did you want to say something?
I was going to ask if this is going to be uploaded on YouTube later.
This is not on YouTube. It's going to be in Blackboard. So you just need to go to the menu, the upper left corner menu of the first page of Blackboard Collaborate, and you'll have access to the video.
Okay, got it. Thank you.
All right. So the question was to find the inverse Z transform of this second degree transfer function, and the method to do that is to factorize g of z first. So it's partial fraction expansion, And step one is to factorize g of z All right, I think there is some problem of Luis Hernandez has a problem. Okay, let me try to continue. So the goal was to factorize this in this form. And this is found by solving the equation z squared plus a1z plus a2 equals 0. Then once you have found them, step 2 is to go ahead with the partial fraction expansion. And this includes two cases. Case 1, this is when lambda 1 different from lambda 2. In this case, the partial fraction expansion, they say that there exist two constants a1 and a2 such that g of z is a1 divided by 1 minus lambda 1 z inverse plus a2 divided by 1 minus lambda 2 z inverse. So this is similar to what you learned with Laplace transform. However, you have to be careful about different conventions with the Z transform. I see someone raising his hand. Mikhail, do you want to say something?
Yes, Professor. My question was, I was actually wanted to ask you this question at the beginning. I want to ask you, have you thought about what will happen to the first exam?
We don't know. We don't know. I have to think about this. Actually, the issue of exams is a world issue. It's not just our school. It's the how to give exams online. This is still not clear. So we'll have to see, and we'll have to see with time.
Professor, is it possible if you let us know when the exam will be? Can we at least have some time to prepare for that exam? For example.
Definitely.
Thank you.
All right. So. How to find A1 and A2? There are two methods. The first method is a method I call method for non-educated people. I know that normally when I teach that in class, I would hear laughters. Here I don't hear them, but I just imagine. So, thank you. All right.
If it's
I got it. Thank you. Now, so this is a method that anybody who has not taken EE306 can always use. The way to do it is to go backward. You write, you regroup them. So you don't know what is A1 and A2, but you assume that this is true. You go backwards. So then you okay. Do you see when? So you have to pay attention. Sometimes I pause here, my cursor looks very small, but you have to pay attention. You know, whenever I move something, I point to A1 here. All right, so here you have A1 times this plus A2 times this, so you get A1 plus A2 minus A1 lambda 2 plus A2 lambda 1, Z inverse. And then you just say that, but since we had this originally, so it implies that you must have this equal to 1 and this equal to 0. So A1 plus A2 must be 1, and A1 lambda 2 plus A2 lambda 1 must be 0. And then you solve for A1 and A2. Now, of course, if there's a method for non-educated people, the next method is for educated people. And this starts from this formula, but there's a way to multiply to find A1 alone. If you multiply G of Z by 1 minus lambda 1 Z inverse, you are going to find A1 plus this times 1 minus lambda 1 Z inverse. All right. Now, if we can make this equal 0, then we'll have A1 alone. So in fact, it's easy to see that if you replace Z by lambda 1, you are going to find 1 plus 0, because this is 0 when Z is lambda 1, and this is not 0, so you get A1 alone. Therefore, you find that A1 is this. Meanwhile, the same formula applies for A2, so you could easily figure out that you get similar formula. And that is the method that I call for educated people. Now, there are mistakes, typical mistakes that students make. But before, let me tell you how to use these formulas. Application. So to find A1, first you calculate this. And since G of Z is equal to this, then what you have here is obviously this times this. But then, very important, this is you want to simplify this, and hence when you replace Z by lambda 1, then you simplify 1 minus lambda 2 lambda 1 inverse. And note that, so, and that gives you A1. Note that if lambda 1 and lambda 2 are equal, then this gives you 1, and then this is 1 over 0. You cannot calculate this. So this tells you why we had to assume lambda 2 different from lambda 1. Same for A2. So this is the time when I can explain to you a typical mistake made by students. It's to do the following, is to say that to calculate A1, you use this formula where you replace z by lambda 1, you replace z by lambda 1, and then you find 1 divided by 0 times 0 undetermined. Right, mistake. If you don't cancel, you're going to get something undetermined, which is wrong. That is the first typical mistake. And second typical mistake yes, I agree with you who is laughing. The second mistake is to replace z inverse by lambda 1. Yeah, I see that mistake often. It's not, we have z inverse, but it's z that is replaced by lambda 1. But a typical mistake, it's z inverse that is replaced by lambda 1. All right, so that is another mistake. So be careful about this. All right. Okay, so now you know how to find A1 and A2. So that means you end up having determine g of z in that form. So g of z originally is in this form. After factorization is like that, and after partial fraction expansion is like that. All right. So, but the goal is to find g of n. Don't forget. All right. So we are in the situation where g of z has been determined like that completely. Now we want to find g of n. Okay, so it's going to be easier to do it because now we have smaller fractions. But before we proceed, I need to give you a property that I didn't mention, a property of the Z transform. That is important. Fardin said something. Linear, it's linear, meaning that if you want to take the Z transform of alpha x of n plus beta y of n, then you get alpha x of z plus beta y of z. It's very easy to see. All right. So now, as a review, we saw last time that if you want to take the inverse Z transform of 1 over 1 minus alpha Z inverse, it is alpha to the power of n u of n. So that is a review from previous lecture. So with these two pieces of knowledge, now it's easy to find g of n, because you say that g of n is the inversity transform of this plus the inversity transform of this by linearity. And the inversity transform of this is A1. So g of n is A1 times lambda 1 to the power n u of n plus A2 times lambda 2 to the power n u of n. And we can simplify this by saying it's A1 lambda 1 to the power n plus A2 lambda 2 to the power n u of n. And we have a formula for g of n, which is the impulse response of the system. But this is only case 1, where we assume that the two poles are distinct. But what about case 2? Case 2. Case 2 is when lambda 1 equals lambda 2. So in this case, we are going to call this common value lambda naught. In this case, g of z appears to be 1 minus lambda naught z inverse squared. Okay, can somebody tell me what do we do in this case with the partial fraction expansion? Yeah, now is the time when I welcome your speaking.
Can you do A0 over 1 minus lambda 0 z to the minus 1 plus B0 over 1
All right.
minus lambda?
While you answer, I get another answer from Shahana, who says that there's no partial fraction expansion. Mikhail, is that the way to pronounce your name, Mikhail?
Yes, Professor. The real way to pronounce my name is Michal. But what I was going to suggest, maybe if you ask a question, maybe instead of everyone answering at the same time, maybe we can raise our hand, so then you can call on people and then we can answer individually.
Okay, what do you mean?
For example,
yes,
you asked us to you asked us for our input, and like people can answer all at the same time. Maybe what we can do is raise our hand and you can pick on us and we can just tell us individually what we think.
Yes, I expected that you would do that.
Okay.
You answer only by raising your hand. You click on the raise hand, and then
you call on us.
And then I call them. So your name is Michal.
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 Yes, sir.
Is it Polish?
It is Polish.
All right. It's different from the Russian name Mikhail.
That's correct.
Okay, I see. Okay, so Sahana said that there's no partial fraction expansion. Yes, you win. All right, so there's no partial fraction expansion. So partial fraction expansion means you try to break this as a sum of small fractions. We can no longer do that. So the only option is to say that g of z is the product of the only option is write that g of z is g naught of z Yes, yes, I agree. I agree. There's not. It's G naught of Z times G naught of Z, where G naught of Z is 1 over 1 minus the naught Z inverse. Manuel, want to say something?
Now that you put there is PFE, you're supposed to put there is not.
Can you say it again? Your audio is really corrupted.
I think that's a mistake. You put there is partial fraction expansion.
The answer is no. The answer is no. You are mixing up with another situation that we may see in the next lecture. All right. So G naught of, we know that G naught of n, if you take the inverse Z transform of this alone, yeah, try to refrain from chatting, okay, during the lecture. Now, G naught of n, the inverse Z transform of this is lambda naught to the power of n u of n. And all right, now if I take this, G of n, then G of n is equal to what? All right, so in this case, I'm asking you, and you need to raise your hand. Luis Hernandez, yes? You want to say something?
Oh, yeah. I just wanted to say that you, in this particular case, you said there is no partial fraction expansion, but in the text it says there is partial fraction expansion. Like where you wrote down, you forgot the not part for future references in case I want to look at the notes.
Oh, this is what you meant.
Yeah, there we go. Okay.
Oh, this is what you meant by, because I thought, all right. Thank you. Now, somebody tells me if G of n is equal to this, G of z is equal to this, what is G of n? Okay, is that Luis Hernandez who wants to talk? Tenzin.
Yeah, I'm gonna assume it's lambda naught raised to the 2n times unit sample.
Sorry.
Oh,
No.
okay.
Sorry. No, but before you go into lambda, and can you give me an answer here in general answer? A general answer.
General answer. I'm not sure about that.
Let's say a safe answer that for which you know you're not making any mistake.
Lambda naught to the n.
No. Somebody else. Nobody can.
Would that be G n convolution with G naught of n?
Yes. Just raise your hand before you talk.
I raised my hand. You never picked me.
What? Yeah, but I don't see your name appearing.
Shrat.
All right. So this is the answer, and then so this is it. So now I want to calculate this. So that it's more complicated because you need to face the convolution. And the convolution has an infinite sum. However, you know the answer. Why do you know the answer? Why do you know the answer? Ah, Manuel says homework 3. Wow, this is good. Bonus. Okay, you're welcome. Homework 3. Question 2. Remember homework 3, question 2, you had a to the power n u of n convolved with b to the power of n u of n. So this is the case where a equals b. So if you did homework 3, you should know this. And the answer was n plus 1 lambda naught to the power of n u of n. All right, so we found just a new formula. If g of z is equal to this, then g of n is equal to that. So we have a new formula. Which is 1 over 1 minus alpha z inverse squared. And I put because this is to be put in your formula sheet. It's the case where you have a second degree rational fraction. And we have finished our resolution. G of n has been found. So I completed the problem. However, there's a difficulty that we have to address. The system that we are considering is real. So remember, it was g of z, g of n is the impulse response of this system. Minus a1 minus a2. Now this is a real system. The a1 and a2 are automatically real because this is a system that is implemented by circuits, and everything in the circuit is real. So this implies that g of n must be real. Why is that? Because g of n is the impulse response, meaning what? Meaning the response of the circuit to delta of n. Now delta of n is a real sequence because it's 0 or 1. So when you have only numbers coming in and everything is real, multiplications are real, g of n must be real. So this implies that g of n must be real. But what happens is that in the let's say above, you can see that lambda 1 and lambda 2 are solutions to this second degree equation. And even though a1 and a2 are real, solutions to this equation, you know they can be complex. And the problem is that in the end, we are going to get g of n in terms of lambda 1 and lambda 2. Like here. Here. So it's a situation which is kind of paradoxical because we expect g of n to be real, but we may have numbers that are complex. So where is the contradiction? So we're going to look at that. So we're going to go again through the two cases. Case 1, lambda 1 different from lambda 2. So remember, G of n was found to be this, where lambda 1 and lambda 2 are the solutions of this equation. All right, so so define delta to be the discriminant of this equation. If delta is positive, you know that lambda 1 and lambda 2 are real. And then it's easy to see that capital A1 and capital A2 must be real also. Just by going into the formula, you can see that that will be the case. And this will imply that G of n is already given as a real expression. So G of n already given as real sequence. So this is the easy case because you are done already. So if I give this case at the exam, it's the good case. It's the good news for you. The bad news is if I give you a case where delta is negative. In this case, lambda 1 and lambda 2 are not real. So now look, they are not real, but they have a very particular expression. If you go into the resolution of this equation, find that the solution of equation gives you two solutions, which I call lambda plus and lambda minus, which are minus A1 plus minus. So you would be tempted to write down square root of delta, but you cannot write this because delta is negative. Square root of a negative number, you cannot write this. So the answer is that square root of absolute value of delta to remove the negative part, and then you multiply this by j. And then you divide this by 2. So this means that lambda 1 is one of them. So let's lambda plus. And the lambda 2, so plus, yeah. And lambda 2 is going to be the other one. So lambda minus. Now look at that. Do you see a certain relation between lambda 1 and lambda 2? All right, so those who want to say something, you raise your hand. Gregory, yes.
They're conjugates of one another?
Yes, they are conjugate. Yes. Manuel, yes. Another bonus? It's teaching online is more difficult, but it's sometimes it's fun. All right. Yes, they are conjugate of each other. You can see lambda 2 is conjugate of lambda 1. Now, there is another way to see that they must be conjugate of each other. Another way to get this result is to say that if lambda is a solution, so this implies that z squared plus a1, I'm sorry, that lambda squared plus a1 lambda plus a2 equals 0. But if this is true, you can say that the conjugate of this is 0. Because if you say that this is 0, then the conjugate of 0 is itself. But you know that this is also lambda conjugate squared plus a1 conjugate, lambda 1, lambda conjugate plus a2 conjugate equals 0. And but we assume that a1 and a2 are real, and you know that a number is real if and only if it is equal to its own conjugate, right? A equals A is real, equivalent to the fact that it is equal to its conjugate. So in the end, you get lambda conjugate squared plus a1 lambda conjugate plus a2 equals 0. So look at this. If lambda is a solution of this equation, lambda conjugate is also solution to the same equation. So that implies that lambda 2 must be conjugate of lambda 1. Because lambda 1, if it's lambda 1 is a solution, then lambda 1 conjugate must be a solution, but the other solution is lambda 2, so lambda 2 is equal to lambda 1 conjugate. So that is another way to see it. All right. So let's return to this. All right. So remember we have this. We have this. Lambda 2 equals lambda 1 conjugate. Now, it can be shown, if you look into the formulas of A1 and A2, it can be shown that A2 also is a complex conjugate of A1. You just need to look, you just need to go into the equation, the formula of A1 and A2. So in the end, what do we have? G1 equals A1 lambda 1 to the power n plus A1 conjugate lambda 1 conjugate to the power n u of n. But this is also A1 lambda 1 to power n plus A1 lambda 1 to the power of n, the whole thing conjugate. All right, so now somebody tells me what this is equal to. So raise your hand when you want to say something. Silence. All right, so let's simplify this question. Suppose A is complex and I add A plus A conjugate. What do you have here? Shahana, please. Yes, what's your answer? Yes. Yes. All right. Yes. Great. Okay, you didn't hear because too shy to speak, right? All right, so A plus A conjugates is 2 times real part of A. Okay, I got you. So this is 2 times the real part of A1, lambda 1 to the power of n, U of n. Okay, so this is good because this tells you that even though you have complex numbers in it, eventually the final answer is that it's going to be real because you're going to take only the real part of this. However, I don't call this a real expression. A real expression is when you only have real numbers in the expression, right? Here you still have complex numbers even though the result is real. So this is not finished. We want a real expression, a completely real, but we want a completely real expression of G of n. So typically in an exercise, you're going to have A1 in the form of a complex number, lambda 1 also. How can you calculate the real part of this? So a beginner would say, oh, but we know how to multiply complex numbers. For example, if you have 2 numbers, you know that the multiplication of 2 numbers, you know how to do that. It's a bit complicated. You get 4 terms. 2 terms are real, 2 terms are imaginary, and you just keep the 2 real terms, and you get the real part. But here you have a power of n. So if n is equal to 2, you're going to get three factors, and multiplying 3 factors together is complicated. But suppose n is 1 billion. Can you multiply 1 billion numbers like that? You will die before you finish, right? So the way to go when dealing with product of complex numbers, you want to work in, okay, what if I write this way? Polar coordinates. So this is where students are very weak because I can see that their preparation in polar coordinates is weak. So let's do some review. In the complex plane, so here I represent the real and the imaginary part. Every complex is a 2D point, a 2-dimensional point, right? So let's say C is a complex number. You know what is the real part, is the projection on the real axis. The imaginary part is projection on the imaginary axis. But how do you read the polar coordinates? Polar coordinates is made of 2 things, 2 parts. The first part is the magnitude. R is the length of the vector that leads C to the origin. And then theta is the angle of that vector. We write that C is R e to the j theta. Both are, so R is, both are real numbers. Now R is exactly the magnitude of C, and theta by notation is, oh, sorry, this is an artifact of my software, is symbolized as angle C when you assume that it's between minus pi and pi. All right, so these are the polar coordinates. So to express this, you want to find the polar coordinates. First, you write the polar coordinates of lambda 1. So we are going to say the polar coordinates of lambda 1 is r e to the j theta. Then you find the polar coordinates of capital A1, r e to the j phi. And once you have that, it's easy to calculate this because it's all multiplications. You get r e to the j phi r e to the j theta to the power of n. And then you find capital R, small r to the n, e to the j. Maybe it's going to, let's decompose this. R to the n, e to the j, n theta. So here you find e to the j n theta plus phi. All right. Now, what is the real part of, so now what we want is the real part of this, okay? So we want to take the real part of this. All right, now challenging, somebody tells me what is the real part of this. Michal, okay?
The capital letter R and the lowercase r raised to the n.
And that's it?
Yes.
Okay, wrong, no bonus. Yes. 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 Georgi?
It's also a cosine of n theta and cosine of phi.
Like that? Like that?
Yes.
With this also?
Yes, I would say
Okay,
yes.
right, correct. Actually, it's not difficult because you know what is e to the j alpha. It's cosine of alpha plus j sine of alpha. So this is the real part, this is the imaginary part. Now, if you have a e to the j alpha, what do you get? You get a cosine alpha plus a j a sine of alpha. You agree? So this is the part, and this is the imaginary part, right? So that's it. All right, this is it. Correct. Let's go back to our G of n. So G of n is like that. So you get 2 times r to the power n cosine of n theta plus b u of n. And this is the final answer. So if you want to have the completely real expression of G of n, it has to be of that form. That what will be expected from you. Okay? Now, did you see something happening, something new happening here? We have a sinusoid here. Isn't that fantastic? Because in this class, we never talked about sinusoids, but they always talk about sinusoids in the previous class, right? Engineering 204 and the EE205, and here they pop up by themselves. I didn't decide to talk about sinusoids all of a sudden. It's not me. It came by itself. Okay. I didn't do that on purpose. I'm not responsible for introducing sinusoids. They pop up by themselves. Right. So that is a message. Now, I didn't finish because I've considered only two cases when delta is positive and when delta is negative. What about delta equals 0? When delta is equal to 0, this is the case where lambda 1 and lambda 2 are equal to each other, and we know they are real. In fact, this case is included in case 2. Case 2. This is the case where delta equals 0. So we know in this case that it's real. Okay, lambda naught is real. So G of n, we found G of n in this form, and it's real. So it's done. In fact, case 2 is a nice case because there's no calculation to perform. You have the made formula. It's already real. So this is the case you want me to give you at the exam. And the case you don't want me to give you at the exam is case 1 with a delta that is negative. All right, so we are done with the full real expression of the impulse response G of n. What I would like to do now, there are two things, is first give you more properties of Z transform. All right, so it's going to be a review. What is the Z transform of delta of n? So I plot it so that you visualize. I mean, you know what it is, but it's nice to see it in front of your eyes. Delta of n. What's happening here? Yes, you can type your answer.
Z? Oh.
No. No. Yes. Yes. 1. Bravo. All right, that was the easy question. Now the more challenging question is coming now. What is the Z transform of delta of n minus n naught? Gregory, wrong answer. Yes. Okay, Shahana gave me the right answer, but the answer, I'm not sure the next answer. So I got this answer, but this is wrong. Is this answer, which is correct. Remember, if n naught is positive, think of the decimal transform. When the index is positive, you are into the decimals. The decimals are negative powers of 10. So that's the way to remember. You need to change the sign here. So this is e to the minus n naught. All right, now I have a harder question. which requires more, which is more elaborate. Can somebody tell me what is the Z transform of x of n minus n naught? Okay, I'm not hearing. Yes, yes, I saw the answer, but I didn't have time to read the name. Okay, so okay. All right. Okay, thanks for this. Okay, I'm going to ask you a question to everybody, but I'm not going to type it. I'm not going to type it. You just listen to what I say. Whenever any of you post an answer by text, do you see it? Sorry, I forgot to click on update question update. All right, I got enough answers to understand that actually you see the answers. All right, so now I forgot if somebody gave me the right answer here. Sorry. In fact, now I'm going to ask you something else, but this time it will require that you speak. For those who found the correct answer here, how do you get to this answer? So somebody wants to say something? Manuel. Okay, Manuel, you speak.
So, can you hear me now?
Yes.
Okay. We can multiply x of n times to, like the delta of n naught.
Yes, except that we don't say times, we say
Cobalt.
yes. Right.
And then, yeah, then we can use the property to find
Fine.
it. Yeah.
Actually, I can see that Shahana displayed this. You use the fact that x of this is equal to this. This is time shift 1. And then you know that the convolution becomes product. So this in the z domain gives you x of z to the minus n naught, which in fact, common practice is to write the z to the minus n naught in front of x of z. It is common practice to put this in front of it because it has the meaning of an operation on x of z. You know, like when you say f of something. So that explains why we like to write this in front of it. All right, so this is good to know this. And this will allow us to go to the next section, which is nth order feedback system. So what does it look like? Since you saw what is second order, then you can easily figure out that the nth order is simply requires to replicate that first stage a number of times. see. So I want to copy that a number of times. Actually, I don't want this. Right, so we have minus A1, minus A2, minus AN. Okay, here, want to all right, so let me finish this drawing. So how do we deal with this general nth-order system? So we start like before. We write whatever we can. We have this equation that y of n is x of n plus the result of all these branches, which give you minus a1, y of n minus 1, minus all the way to this. And we want to rewrite this by putting all of the y's on the left side. This time you get pluses here. This is called difference equation. All right. So the question is, what is g of n? And the answer is, so g of n is such that it is such that y of n is g of n convolved with x of n. So how can we find it from this difference equation? There's a very easy way to do that. Take the z transform of this. So on the right side, you have x of z. And on the left side, you use linearity. You get the z transform of this plus the z transform of this, etc., plus this. The z transform of y is y of z, plus the z transform of this is a1 times the z transform of y of n minus 1. What is the z transform of y of n minus 1? Somebody. What is the z transform of y of n minus 1? Somebody talks. Yes, okay, so yeah, Manuel, so you can say.
That will be y of z
Yes.
times, go up, where you have the,
So you said y of z times what?
can you go up? You know, where we have the, right there. So that will y of z times, I'm sorry, c times y of z, b y of z.
Okay, y of z times what?
No, y of z divided by z. Is it?
Yes. Okay, so it's z to the minus 1 y of z. In fact, the answer was displayed by, I forgot who. All right, so you get this, and then so the next will be a2 z to the minus 2 y of z, and the last one will be an z to the minus n y of z. All right, so now what is nice about this is that you can factor out y of z. You are going to find if you factor out y of z, you're going to find this. All right, so this. All right, so now, since we have this in the time domain, we know that in the z domain here we get y of z equals g of z, x of z. But since we have this equation, then we know that g of z must be the inverse of this. So this implies g of z is nothing but the inverse of this. All right. All right, so then what is left to be done is find g of n by partial fraction expansion applied to the higher degree n, which we will do next time, because this is where I ended my lecture this morning. So this is the end of the lecture. I'm going to remind you that this Wednesday we have official class at the same time, and homework 5 is due next Monday, and the submission is electronic, and it's automatically it will be automatic as soon as you click on homework 5 in the assignment entry. And I have to warn you, homework 5 is intense in algebra, is very intense in algebra. You need to start doing it ahead of time. All right? Okay, so I'm going to stop the video, but I'm going to leave this session open in case you have questions. Georgi, yes?
In case when we have complex numbers, we have theta and phi angles, how do we find them? What are we supposed to do with the angles?
Oh, so typically, you know, I'm going to give you a simple example. Suppose the complex number is 1 plus j. Suppose. Then graphically, if you look at the graph, you're going to see is that the complex number is like that. One, all right? So then you know that this is pi over, this is pi over 4. And you know that the length is square root of 2. So C is square root of 2 e to the j pi over 4. Yeah, this is an example. This is an example of how to find polar coordinates. Yes, Rashidu, I don't know how to pronounce.
Hello, Professor. So about the homework 5, how are we supposed to submit it? Through email or Blackboard?
No, it's when you click on it, when you click on homework 5, you'll be automatically led to the electronic submission.
Oh, thank you.
Because now the homework 5 is in the mode of electronic submission. So as soon as you click on it, you will be led to the electronic submission.
Okay, thank you.
Yeah, somebody said you just need to upload things. Yes, nice. Yes, yes, that's true. Yes. All right. So this is the end of the lecture. You can stay here if you want to ask more questions. Yes. Yes, Manuel. Yeah, exam 2, exam 1. Yeah, I don't know. I have no idea. Talking about exams, I have no idea. Just telling you something. In France, all universities are closed and they are going to give exams, but I don't know how they are going to do it. In fact, even in the news, they say that it's a big issue. Zakia, yes?
Hi, Professor. So I just wanted to know if we have any questions regarding the homework problems. Can we send you an email and communicate with you if we need help?
So you mean you're talking about office hours?
Yes, yes, exactly.
Yes. So the way I see it is that I will let you send me emails more often than usual to replace office hours.
Okay, thank you so much.
Okay, you're welcome. You cannot cheat in systems. You say, Manuel, you say you cannot cheat? Uh, talking about email, try to be reasonable when sending emails. I mean, prepare your question well. I mean, think about the question well. And often my way to respond to answer the questions is not so explicit because I give you hints, but I don't give you explicit answers. I try to make you think about your question more. But in general, as I said, what is most important is that you think about the homework. It's the fact that you sweat on the homework that is more helpful than the grade you get in the homework. And you, somebody asked if the virus can go internet. Is that the question? I hope, yeah, I hope it doesn't go through. All right. So, okay, really, these are all the questions about exams. It's as I'm telling you, it's so new that even in the nationwide, we don't have the answer yet. So that in any case, when we make a decision, I will let you know long in advance enough so that you have time to get prepared. In any case, yes, notes are uploaded. Yes, I will upload. Same system, except for the video. That the video is not in YouTube; it's in Blackboard. It's in the first page of Collaborate, the upper left menu. But you have to wait for the video to appear. Once I send it, it takes maybe 15 minutes to be compiled. So I'm going to start the video actually now.